Vectors sound complex, but they're really not. They're kind of coordinates that you can plot on a graph as a line drawn between two spots, so don't let your brain get tied in knots. We can represent it with a series of numbers, usually placed in columns with braces. The numbers x, y, z, we call them, the axis in your coordinate system. Obviously, the line has length, and so do vectors, but another strength is that it also has a direction. Just like an arrow. Where's my rhythm section? Vectors that are complicated, their usefulness is underrated. With more than one vector, we can add them together. Look at the diagram, learn from this, be clever. Naturally, we can also subtract them. This is the opposite of adding some. Scaling a vector is also simple. It simply scales the length, which is useful. It lets us do something called normalization. But you say, well, what intonation is that? It just means the length is 1, which is helpful when we want to do a dot product on them. So what the hell is a dot product then? I'll explain it now. It's essential when you want to compare the direction of vectors. The dot product tells us how similar they are. 1 if they point in the same direction, to -1 if they're opposite. Additionally, it can be used for projection, which allows us to split vectors into components. This means we can avoid doing trig, avoiding angles, which is often a big win. Finally, there's also the cross product, not used so often, but simply the boss for finding a perpendicular vector, and you don't even need a protractor. Vectors that aren't complicated, their usefulness is underrated.